Think about a masterful pianist whose fingers just literally blur across the keys. Or maybe a math prodigy who can visualize massive, complex equations in an absolute instant. I mean, the scale of their ability just feels totally otherworldly, right? But here is the ultimate biological thriller. They are operating with the exact same fundamental evolutionary hardware as you. So how on earth is that even possible? Well, that is exactly the core mystery we're unraveling in this video today. You see, society holds on to this deeply ingrained misconception that human neurological hardware is just identical across all individuals. But let's really think about that. If the hardware is totally uniform, how do we explain profound innate genius? Listen, here is the high-stakes biological reality. Modern neuroscience categorically refutes the idea of a standard uniform brain.
Chapter 2. The Connectome's Fingerprint. All of that cortical variability we just talked about, it forms a highly distinct, readable signature called your connectome. You know, there is no single magical genius center hidden somewhere in the brain. Instead, we rely on something called the parieto-frontal integration theory, or PFIT. This shows that intelligence depends entirely on how rapidly sensory data flows through a widely distributed network of brain regions. It's all about how fast your brain can pass a signal without degrading it. And this network is so incredibly unique to you. Researchers can literally identify you from a massive crowd with 99% accuracy just by looking at your functional blueprint. Crazy, right? And that actually brings us to a stunning biological paradox known as the neural efficiency hypothesis. Now, you might think a genius working on a really complex problem has a brain lit up like a Christmas tree, right? Well, the exact opposite is true.
Highly gifted individuals and expert athletes actually consume less brain energy. They exhibit lower neural activation for routine tasks. Why? Because their neural circuits operate at way faster speeds and with far greater metabolic efficiency. They are essentially automating the routine stuff so they can save all of their explosive processing power for the truly novel challenges. Chapter 3. The Genetic Blueprint. 41%. That is the heritability of general cognitive ability in early childhood. Behavioral genetics has now firmly established that our cognitive abilities are highly heritable. They're anchored in thousands and thousands of tiny DNA variants, all acting together, kind of like a polygenic score made up of countless miniature biological advantages. But okay, here is the twist. You would naturally expect that as a child grows up, goes to school, and just experiences the world, environmental factors would start to overshadow those genetics. But no. Instead, the heritability of intelligence actually leaps to 66% by young adulthood. Yeah, your genetic blueprint actually becomes more dominant as you age. And get this, it's not just about general intelligence either. Specific talents, things like processing speed, musical aptitude, or quantitative knowledge, those have an average heritability of 56%, and they operate largely independently of general intelligence. So what does that mean? It means you can absolutely possess the genetic architecture for highly specific, extraordinary talents without necessarily having an exceptionally high overall IQ. So why exactly does genetic influence increase over time? Well, it's because genes don't just passively sit there doing nothing. They actively hunt for their ideal environment. This is a concept called gene-environment correlation, and it basically happens in 3 stages.
First up, passive. Like when gifted parents raise a child in a naturally enriched home. Second is evocative. This is where a child's innate curiosity literally forces their teachers to offer more advanced instruction. And finally, active niche picking. As individuals gain more freedom, they actively construct environments, say by joining a robotics club, that perfectly maximize their specific genetic potential. It is a relentless, constantly escalating feedback loop. Chapter 4. Forging the Brain. The old saying goes, genetics load the gun and the environment pulls the trigger. But the actual bullet? That is physical change. It's a highly volatile collision. You definitely have innate predispositions, But to actually actualize that talent, your brain absolutely must physically reorganize itself through what we call experience-dependent neuroplasticity. We see this all the time, like in expert London taxi drivers whose spatial memory centers physically expand, or musicians who build noticeably thicker white matter tracks to bridge their brain hemispheres, allowing for that super rapid hand coordination. Now, for decades, society was fed this extreme environmentalist myth of the 10,000-hour rule. You know, the idea that expertise is purely the result of grueling, deliberate practice, completely dismissing any role of innate talent. Well, modern science utterly destroys this idea. The multifactorial gene-environment interaction model shows us that yes, practice is necessary, but it dynamically interacts with your genes. I mean, just think about it for a second. Even the psychological traits required to actually sustain 10,000 hours of grueling practice, traits like conscientiousness, deep motivation, and emotional resilience, those are deeply heritable themselves.
Yet, when that genetically driven motivation meets relentless practice, a literal biological transmutation occurs in the brain. It happens in 3 distinct steps. First, transient exuberance. This is where the early brain creates a massive, massive surplus of synapses. Second, synaptic pruning. Specialized microglial cells come in and physically eliminate any redundant pathways, which massively increases your signal-to-noise ratio. And finally, activity-dependent myelination. This is when lipid sheaths wrap tightly around active neural axons, finally tuning the speed of those action potentials. This ensures that signals arrive across your brain simultaneously. Guys, this right here is the literal physical biology of becoming a master. Chapter 5, Prodigies and Savants. Now, to truly understand the absolute boundaries of our human hardware, we've got to look at the extremes. We see this incredibly clearly in Savant Syndrome. These are individuals who might have severe developmental disabilities, but they exhibit these astonishing islands of genius in areas like math, art, or memory. But why? Well, it's because they possess privileged access to raw, low-level, completely unedited sensory information. You see, your neurotypical brain naturally filters a complex visual scene into a simple semantic concept just to save energy. A savant completely bypasses those filters, absorbing the exact raw gradients of light and shadow. So you're probably wondering, where exactly is that filter? It's primarily located in the left anterior temporal lobe, or the LATL. This region categorizes all your inputs and forces top-down inhibition. In savants, this area is often dysfunctional.
But here's the most terrifying and honestly thrilling revelation of all. Researchers have actually used magnetic stimulation to temporarily inhibit the LATL in completely typical volunteers. And the result? They temporarily induced savant-like artistic and mathematical abilities in perfectly ordinary people. The genius hardware exists universally, inside all of us, but your brain is actively suppressing it right now for evolutionary efficiency. No way, right? Another fascinating extreme phenotype is synesthesia. This is a condition where people literally hear colors or taste words. And biologically, this is a genetically driven failure of that exact same synaptic pruning process we discussed just a minute ago. The brain regions responsible for different senses remain permanently hyperconnected. It is such a vivid reminder that just tiny, tiny genetic variants in our developmental trajectory can radically alter our everyday reality. And, of course, our resulting talents.
Chapter 6, The Final Equation. We have completely mapped the architecture of ability today, taking it all the way from the sheer expansion of the cortex right down to the microscopic molecular pruning of our synapses. Human talent is not some mystical gift dropped from the sky, nor is it just the mindless repetition of 10,000 hours of practice. It is an active, highly volatile collision.
It's the phenotypic endpoint of a totally customized neural connectome, forged by this relentless, unbreakable feedback loop between your unique genetic code and very specific environmental catalysts. The hardware is in there waiting. So the only question left for you is, will you actively shape your environment to trigger your potential, or will you just let your connectome lie dormant? Thank you so much for joining me on this incredibly deep journey through the neuroscience of talent. If you want to uncover even more of these fascinating, high-stakes realities hidden right under our noses in our biology, definitely make sure you hit that subscribe button and click on the screen to watch another interesting video like this one.